Hey guys, so in this lesson, this is lesson one of the Python beginner course. Again, this course is ideal for beginners who are starting to have interest and learn some basic concepts of programming. And in this case, we're going to be focused on Python specifically. So in this lesson, guys, this is the compiled versus interpreted lesson. So I will be discussing with y'all again on a basic level what's the difference from compiled and interpreted, because maybe you have heard one or the other. And what is Python? Is Python considered compiled or interpreted? So that's what we're going to be discussing and reviewing in this lesson. So let's start off with the first piece. Is Python considered compiled or interpreted? So Python is a interpreted language, guys. I'll show you some examples of other interpreted languages in a minute, and also the difference of what compiled. But Python itself is an interpreted language. This means that the program is translating high-level machine-readable source code into low-level machine-readable target code line by line. So ultimately what that means is, as you write Python code, you need an interpreter. And I will be showing this on my next lesson on installing an interpreter on your machine. Depends on what your operating system is. Linux, Mac, a lot of these operating systems come with Python already installed. But nevertheless, we'll walk through the process on how to get that set up, and that will be the next lesson. But you need an interpreter as a piece of software. Think of it that way, that as you write Python code, it's going to translate your human readable code over to machine code to ultimately execute what needs to be done. Python is a interpreted language. What does compiled mean, right? So again, we have two types. We have compiled and interpreted. Well, we know Python is interpreted because we just talked about that right now. So now let's look at, what is compiled? So compiled language are programming languages that must be translated to machine readable instructions using compilers. So just like in Python, you need an interpreter to interpret your code over to machine code. When you're writing code in a compiled language, after you write your code, you cannot run it and test it as is. The way it works is you have to compile it first. There's a process to compile your code, all of your code, which means your code has to be functional. All of the code that you have has to be in good working order. There cannot be any bugs. Everything has to be set error-free for the most half, right? And then ultimately, you will compile the whole application, the whole program, over to machine code, which think of that as like a .exe file. And that's after it's compiled, then you can run your application to test it out, to see if it works, any issues, things of that nature, right? So that's kind of what that means. Instead of being where Python, you write pieces at a time and you can run your code right away to see if it works, any issues, things of that nature, because it being interpreted line by line as you run your code. You can make updates on Python as it runs. You could write a new line of code, and it would ultimately, you could rerun it and it'll kind of tell you right away what the results are. Or if there's errors, you get an error. Where again, compiled, you can't do that. You got to compile the language. You got to compile that to machine code first, and then you can run it after the fact. So that's kind of, from a high level, that's kind of the difference of compiled. When you hear compiled, again, think of it, maybe you've seen exe files. Those are compiled applications, and that's kind of what that means. So let's kind of walk through an example, right, of a interpreted language. In this case, Python. So this is actual Python code. So again, if you're learning Python, this is 4 lines of code that's doing very basic functionality, right? So all we're doing is summing up X and Y. Right? Nothing fancy. We're assigning the number 5 to X, and then number 7 to Y. And then we're pretty much saying we're creating Z. Z is the total of X and Y. And then in the bottom, we're printing out the results. and this will get printed out like in the terminal, command line, etc. But it will be printed out, and that to be able to see the results. To, you know, again, very basic aggregation, 5 plus 7, which we know is 12, and that's what we would get back. Well, this human readable code would be interpreted by the interpreter, because you need an interpreter, and ultimately converts it to machine code. Now, something to keep in mind, right, is it's converting machine code one instruction at a time, right? So again, if you have an application in Python, let's say a big application, it's not converting all of that to machine code at once. It's doing, think of it as one section at a time, piece by piece. As it converts one piece at a time to machine code, then it runs that program line by line. And then it converts another section of instruction to machine code, then it runs that piece. So that means it could run, you know, a few sections successfully. Then eventually you get down to maybe a section where there's an error. Let's say, for example, the print statement, we mistype print. So again, print is a function to be able to see some kind of results on the terminal or command line. But let's say we mistype it, the T ends up being an I, something of that sort. Well, because it's not a valid function, it's going to error out by default. So, but it won't error out right away. It's going to process this, right? Convert to machine code, is going to run it. It's going to take line 2, process it, run it. Line 3 is going to process it, run it. By the time it gets to line 4, it's going to error out. That's what's going to happen in this flow. So that's kind of what's happening underneath the hood. Again, from a high level, but that's ultimately what's happening here. So again, that's why you could run your code, and if there is an error, you won't know what that error is until it actually runs. You know, and that's just kind of an example of how Python code gets converted and ultimately gets ran. Now let's look at compiled, a compiled language. In this case, where the example is C++. And again, this is actual code as well. So, I mean, you could tell C++ a few more additional lines of code to do the same thing ultimately. But I'm not going to go into detail what all of this means, the namespace and include, because again, this is not a C++ tutorial. But nevertheless, we have our main method, and inside here we're declaring x equals 5. Again, it's an integer, so we got to specify that it's an integer. We have y equals 7, and then we have z equals y plus 7. Again, very similar to what we had before in Python. And then we're pretty much printing that out in the terminal. Now, the difference here is when we want to run this code, we have to compile it first. But when we compile it, it translates the whole source code. So it's taking all of this and going to compile everything first, right, to machine code. Not like Python where it was doing it line by line. This is going to take everything. Now, one of the benefits of compiling is if there's any errors, whether it be data type errors, whether it be maybe this is spelled wrong, etc., right? Any of those kind of errors, it's going to throw an error when you try to compile. So you will know in advance, like, hey, there's something wrong here because the compilation process failed and you cannot compile the application. So before you even try to run it, you will know there's an error and you'll be able to fix it. And then, but ultimately, once if everything's correct, you compile the whole source code, which is what would happen here. And then now that you compile the whole source code, now you'll be able to run the whole application, the whole program. And because of this process, everything should be fine. Everything should be error-free. And it's actually going to run fast. If you're, again, those who are new, C++ is way faster than Python. And that's a whole different discussion on performance. But do want to put that out there because in general, compiled languages are way faster than interpreted languages. So just kind of keep that in mind. Now, that's not necessarily an issue in most cases, but that's still something to be aware of and keep in mind. So let's look at some other languages here. So some of the other compiled languages that we have here would be C, C++, C#, Go, Rust, just as an example of a few. And interpreted languages will be JavaScript, again, web. So if you're dealing with web, it's an interpreted language. Ruby, PHP, again, a lot of these are web languages that's used heavily for web. Perl, it used to be used a lot for web back in the day. I think now it is still used in some areas, but probably more for like backend or data type stuff. And of course, BASIC, very old school. But nevertheless, these are some examples of other languages that are compiled and interpreted languages. So let's kind of review some key differences here, right, between compiled and interpreted. So let's look at compile. Process the whole application at once. Kind of what we saw. Whenever you compile your source code, it needs to compile everything. Where Python will process the program one instruction at a time. It does piece by piece, and then it runs that code, right? So it compiles, then runs, compiles, then runs. Now, because it's doing this multi-step compiling on the fly, running it, that's one of the reasons why it's not as fast. Even if the compile process, let's say, takes a while, but when it comes to running the code, you don't need to compile no more. It's already been compiled. You're literally just running it. Where in the interpreted language, you actually have to compile on the fly, and then you'll be able to run it after that. But that's one of the differences. Translate whole program to binary machine code, then the program can run after that. Kind of what I've just mentioned right now. Compile everything first, then you run the application. Execute the program by translating instruction one by one on the fly. Again, one by one on the fly. And then, of course, you have errors. It will error out throughout the process. In this language, the compilation error prevents the code from compiling. Again, if there's an error in your compile process, it's going to error out in advance. Now, that's good that it errors out in advance, because you'll be able to catch some of these errors before the application gets released out to the public. In this language, all the debugging occurs at runtime. Again, if there's errors, you won't know it until you actually run the code. So that's something which is why in interpreted languages, there's a lot of testing that needs to be done to try to identify different scenarios that can cause errors to try to address it up front. This language delivers better performance. So again, because compiled, is going to be way faster. It's already compiled, you got to run it. Where interpreted languages, this language example delivers relative slower performance. So here's the thing. When you compare the two, without a doubt, interpreted languages are way slower than compiled languages. Keep that in mind, because that is true, right? One is very slower than the other. Now, that being said, it doesn't mean that the language is slow per se for what you're trying to do. There's other factors that come into play. Let's say you're going to create a web. Most web applications that exist right now in the world, they're not necessarily created through compiled languages. There are some out there, right? C#, .NET, Java, Spring, etc. But you have a lot of PHP. That's an interpreted language. You know WordPress, PHP. That's PHP. There's a lot of websites out there that are built on PHP. There's Python apps that are built out there, websites as well, using Django, Flask framework. Same thing with JavaScript. Like the list goes on. And when you compare the two, if you were to have two websites that are identical, one using, let's say, C# and the other one using JavaScript, for example, you may not even notice the difference. They're going to perform just as fast. And that's because even though, let's say JavaScript, because it's interpreted language, it is tens of times, many times slower than C#. But when you implement it in real world scenarios, that speed doesn't really benefit you as much, because there's other constraints that you have to deal with. Internet speed. It doesn't matter how fast the language is. If my computer where I'm at, I have very slow internet, it's going to be slow regardless, right? I mean, there's all these other scenarios. But even if you have fast internet and everything, you have all the best case scenarios, in majority of cases, you're not really going to notice the difference of performance. Because it could literally just be in the matter of a few milliseconds. And that sometimes is not noticeable. So that's just something to keep in mind. Then, of course, we talked about some of the other languages, compile languages, C, C++. Same thing with JavaScript, interpreted Python, JavaScript, etc. So again, guys, hopefully these videos that I'm making are beneficial for anybody that's new. Again, there'll be part 2 will be coming out soon. Part 2, it will be getting started video where I'll walk through the process on installing the Python interpreter, and then how to use it, how to launch it, and do some very basic stuff with it for now. And then we'll kind of go from there. Again, guys, appreciate it. Hopefully these videos are beneficial to y'all. And yeah, see y'all next time. Peace.